So today we are going to discuss about the outlier. So what is the outlier and how we'll handle the particular outlier? We are going to discuss about that. So what is the outlier? See here, in statistics, outlier is the data point that differ significantly from other observation. If we are considering this is the straight line, this one is the outlier because it is significantly different from other point. Okay, so we will handle the outlier. Sometimes we'll remove the outlier and sometimes we'll give the particular outlier. So when we'll remove the outlier, consider you have one data set and in this particular data set the human age is like 300. So it is practically not possible. In this type of case, we will simply remove the particular outlier. When we are removing the particular outlier, this technique is the trimming. When we are keeping the particular outlier, the technique is the capping. When we will keep the particular outlier, consider the data set. Here, some student is studying 2 hours and her CGPA is like 2. Some students are studying 4 hours, her CGPA is like 4. One student is studying 6 hours and her CGPA is the 6. Now, one student came who is studying only 1 hour, but her CGPA is like 7. So, it is not a abnormal. It is the normal case only. So in this type of case, we will keep the outlier. So this is the capping technique. So we'll discuss about the two technique. One is the trimming. That means we will remove the particular outlier, and another one is the capping. There we will not remove the particular outlier. So let's see. So first of all, here I have import my important library. For each and every data science project, we have to import this 4 library. That is the NumPy for the numerical calculation, Pandas for the data handling, Matplotlib and Seaborn for the data visualization purpose. After that, I have read the CSV data. I have already uploaded in home. Now I have read that particular CSV data. After reading that particular CSV data, I want to check the particular rows and columns. That's why I have just simply written here df.save. So here 1000 is my row and 3 is my columns. After that, I want to check the data. So if I'll write df.sample5 and I'll run this, see now. Now I got 90, 395, 676, 13 and 733 row. If I again run, see, now it changed. So the sample, it will give the random data each and every time. How many times I'll run, it will give the different data. Okay, now I want to check the distribution of the particular CGPA and the placement exam marks. There are 3 columns. One is the CGPA, one is the placement exam marks, another one is the placed. Based on that, the machine will predict the student will be placed or not. So after checking that distribution, I got to know the CGPA normally distributed, but the placement exam marks is not normally distributed. So now here I want to check the average standard deviation, minimum and maximum. I have checked this. Here I have found out the boundary. How I have found this? See, if the data is the normally distributed, so we can apply the empirical rule. So what is the empirical rule? Again, we will go in that particular PDF and see here. 68% of data falls within the first standard deviation. 95% of data falls within the second standard deviation. 99.7% of data with falls under within the third standard deviation. If any data will falls under the mu plus 4 sigma and mu minus 4 sigma, we'll consider it will be a outlier. After 3 sigma plus 3 sigma and minus 3 sigma, we'll consider it will be a outlier. So the highest range will be plus 3 sigma and the lowest will be minus 3 sigma. So that's why here I have just applied the mean of CGPA plus the standard deviation of CGPA. 3 standard deviation of the CGPA. And what is the lowest value? That is the mu minus 3 sigma. That means mean of CGPA minus 3 standard deviation of the CGPA. So if the data is the normally distributed, then we can apply the particular empirical rule. Otherwise, we can't. Okay, see here. Here, what is the highest value? That is the 8.80. What is the lowest value? That is 5.11. So, greater than 8.80 and less than 5.11 will be a outlier. So, here I got the 5 outlier. So, here I have removed the particular outlier and I am considering those data which is less than 8.80 and greater than 5.11. Here I have removed the particular outlier. Okay. Now, after removing my outlier, my row is the 995 and my column is the 3. Now here I have applied the z-score. Again, I am going to the PDF file. So what is the z-score? See here. I want the normal distribution to a standard normal distribution. So what I will do? I'll perform the standardization technique. For that, I'll perform the z-score, or we can say that the standard score as well. So what is the formula of the z-score? The formula of the z-score is the x minus mu, that means mean, by sigma, that means standard deviation. And what is the range? The range of z-score is the -3 to +3. So that's all. Here I have written first the x minus mu by sigma. After that, if any data greater than 3 and less than -3, it will be an outlier. See here, the 2 data is greater than 3 and the 3 data is the less than -3. So it will be what? It will be an outlier. Simply here what we have done, what data greater than 3 and which data less than 3, I have combined those data. Now I got the 5 data. So what I will do? I can do 2 things. One thing, I can simply remove the outlier. And one thing, we can keep that. So here I have simply removed my outlier which is less than 3 and greater than minus 3. I only kept that data which is greater than 3 and less than minus 3. I will keep that data or I'll remove that data. I'll remove that data which is less than which is less than 3 and greater than minus 3. That means no outlier. I have only kept that particular data. And again I got what? The 995 row and the 4 columns. Why 4 columns? Because here I have added the CGPA Z score. Now, here again I have calculated the upper limit and lower limit. It will be same only. Mu plus 3 sigma will be my upper limit and mu minus 3 sigma will be my lower limit. Now, I want to keep the data. This is the capping technique. What I will do? I will just replace. See here, my maximum data is what? My maximum value is the 9.12. I want to replace the 9.12 with my highest value, that is the 8.80. And what is the minimum value? My minimum value is the 4.89. I want to replace 4.89 with 5.11. Here, using the np dot where first it is searching. If any data greater than upper limit, it is just replacing with the highest value. If any data less than upper limit, less than the lower limit, it is just replaced with the lower value. What we got from the mu plus 3 sigma to mu minus 3 sigma. It is just replacing the value. Now, if you want to check the shape, it will be same because we have not deleted any data. Now, see here, I want to see the statistical summary. So, here I have written the CGPA of the describe and the maximum data is the 8.80. What we got from my empirical value. And after replacing, my minimum value is the 5.11. So that's all for today's video. Thank you everyone.